Okay, so the first special right triangle we're going to talk about is a 45, 45, 90 triangle. So that means that its angles are 45, 45, and 90. Okay, so let's think about that triangle before we start talking about what we need to learn for this chapter. It says, what classification can you give it? Well, we can classify a triangle by its sides and by its angles. Let's do the angles first. That's probably the easier one. It's got two acute angles and one right angle, so we would call it a right triangle. Then our options for naming it by its sides are scalene, isosceles, and equilateral. So looking at its angles, two of the angles are the same, and by the base angles theorem, we know that means two of the sides have to be the same. So this is a right isosceles triangle. Okay, draw a picture and label the sides. So I'm going to draw a right triangle. I want these two sides to be the same. I know that these angles are 45 and 45. Okay, so we have a hypotenuse, and these two sides are the same. So I could put this side's A, then that side would be A. Okay, so I don't need to use A and B like we normally do in Pythagorean theorem, because they're the same. So we could do A squared plus A squared, since they're the same. Okay, so now it says, use Pythagorean theorem to find the general lengths of a 45, 45, 90 triangle. So what that means is, in the picture we had on the other page, we had two sides that are A. The hypotenuse is still C. I wrote an A again. Okay, so let's do Pythagorean theorem and see if we can figure out what C equals. Okay, so we have A squared plus A squared equals C squared. We want to solve for C squared, or we're going to solve for C. So I can combine the like terms here. You get 2A squared equals C squared. And then remember, to solve for a variable that's squared, you take the square root of both sides. Put that in a different color. So I would do this. And then this squared and this square root are going to cancel each other out. So all we have left on the right side is the C. And on the left side, we can break this up into two pieces. You have the square root of 2 times the square root of A squared. Now the square root of A squared, once again, the square root and the squared are going to cancel out. So you have the square root of 2 times A. We would write that as A root 2. Okay, so the general side lengths for, if you have a 45, 45, 90 triangle, and draw it here, you have, I don't have to write the second 45, because if you know two of the angles, that last angle has to be 45. So these two sides are the same, and this side you can say is A root 2. Okay, so you only need, if you know one side of this triangle, you can figure out the other two. Okay, this is something you can only do with 45, 45, 90 triangle. So let's do a couple examples of this. So in this first example, the first thing I would do is go in and mark down this general form on top of this picture. The two sides that are the same are on either side of that right angle. So this side's an A and this side's an A. And then the hypotenuse is A root 2. So looking at what we have, I'm going to zoom in here. Looking at what we have, 8 is on a side that's marked as A. So I know that 8 is the same thing as A. Every time I see an A, I'm going to put an 8 there. We're trying to find this side, and that's A root 2. So that is going to be 8 root 2. And that is your answer. Okay, let's try another one. So for B, I'm going to start by copying this formula onto this picture. The two sides that are the same are on either side of the right angle, so they are A and a, and the hypotenuse is a root 2. Okay, so looking at what they gave us, both of these have a square root of 2 in them. A is just the number in front of the square root of 2. So I know that a has to be 5. So down here I would put a 5 on both of these sides. So x is equal to 5, because both of these are 5. Okay, let's try this one, okay? This is going to get a little bit more complicated now. So I'm going to mark the same formula that we used in the other two. These are the sides that are the same. That's a, and the hypotenuse is a root 2. Okay, now we have a problem because there's not a square root of 2 in this question, but I know that these two have to be equal to each other. So you're going to make an equation. A root 2 is on the side that's marked as 5. So if I take this equation and solve for a, you will get the answer that we're looking for. So this means a times the square root of 2. So you know from algebra, to get rid of times, you have to divide. So I'm going to divide both sides of the equation by the square root of 2. Those cancel out. So I have a equals 5 divided by the square root of 2. We can't have a square root on the bottom of a fraction. Remember back from when we were doing, I think I have it right here. Back when we were talking about square roots, you can't have a square root in the denominator, so we had to do this whole rationalizing. You're going to have to do that again here. So we are going to multiply the top and the bottom of the fraction by the square root of 2. And that will give you 5 root 2 on the top over root 2 times root 2 is square root of 4. Square root of 4 is 2. You can check if you can reduce this by covering up the square root with your finger. Look at what you have left. I have a 5 divided by a 2. That cannot be reduced, so that is your answer. That is what a equals. X was on the side that's just a, so that is your answer. Okay, let's try one more. Mark the sides of the triangle. So either side of the right angle is the a's, so a, and then the hypotenuse is a root 2. There's not a square root in this one, just like there was up here. This one was kind of the easy version where we knew a had to be the number in front of the square root. So we're going to have to set up an equation like we did over here. 8 is on the side marked a root 2, so a root 2 equals 8. To solve this, you divide by the square root of 2. Those cancel out. And then we can't have a square root of 2 in the denominator, so we're going to rationalize the denominator. Multiply across, you get 8 root 2 over square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. I'm going to cover up the square root of 2 to see if I can reduce that. That does reduce because 8 divided by 2 is 4. So we got 4 root 2. That'll be the sides for a, which is what we were trying to find. So that's our answer. Okay, I want you to try these two questions. Come back when you have your answer and check your answer against mine. Okay, so for number 1, you should have marked it a, and a root 2. This is one where they gave us, there's a square root of 2 in the hypotenuse already. So the number in front of the square root of 2 is going to be our answer. So that's a 2. So the x's should be 2. For this one is a little bit challenging. You should have a root 2. Okay, so a is equal to the square root of 2 on both of these sides. So even though it looks like there's a square root of 2 in this one, we have to change the a to the square root of 2 because these sides are the square root of 2. So we get the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So this side is going to be equal to 2. Okay, let's try this example. And that's all we're going to do for this video. So the question says, got a pen in here. There we go. You plan to build a path along one diagonal of a 100-foot by 100-foot square garden. There's kind of a diagram of it here. To the nearest foot, how long will the path be? So that's the question. We're going to use these parts to break it up into pieces. So use the words path, height, and width to complete the diagram. So the path is the diagonal. So we're going to put this is pointing at the path. The height, it doesn't really matter which side you put it on. I think height is this side. And the width is this side. It said it's a square garden, so I know all these are right angles. Okay, write L for leg, H for hypotenuse, to identify each part of the right triangle in the diagram. So the path is on the hypotenuse. The height is one of the legs, and the width is one of the legs. Substitute for the hypotenuse and the leg. Let H equal the length of the hypotenuse. So substitute for the hypotenuse. Let H equal the length of the hypotenuse. What in the world are they wanting us to do? Solve the equation using a calculator. Okay, so this is the hypotenuse is, we learned from up above, if I used our formula on here too, we have A, and then this side is A root 2. So that's all they're saying right here. The hypotenuse is the square root of 2, we have that, times the length of the leg. And we are using an A to represent the length of the leg. I'm going to skip this part because I just labeled the diagram with the formula that we know. This says solve the equation using a calculator. So we're going to give our answer as a decimal, or we're going to round it to the nearest foot, since this is actually something that would be measured out if you were making a garden. If you went to Lowe's and said, I need bricks that I can line up and it'll be 7 root 2 feet long, they're going to look at you funny. They will want to know exactly how many feet there are without square roots. So the legs are 100 feet long. So we want basically to figure out 100 times the square root of 2 will be the length of that diagonal. So 100 square root of 2 is 141.42. It says round to the nearest foot, so the number after the 1 is a 4. We would round down and get it's going to be about 141 feet path. Okay, try some of these on your own.